Use mental math to calculate the percent. Well, half, 50% of 36 would be half of that, which is 18. So half of a half would be 9. So if we wanted 75%, we would need 50% and 25% combined, which would give us 27. So you can think of half of 36 is 18. A quarter of 86 would be 9. So 75% would make 27. Please complete the remaining 3 problems for your warm-up. A restaurant owner notices variability in the number of potatoes she uses. She counts and records the number of potatoes she uses each Saturday for 24 Saturdays. The dot plot and the data set show the data values she recorded. The vertical line segment in the data set marks the median. What is the median of this data distribution? How do you know? Label this value under the segment, under the vertical line segment that in the data set. Well, between 81 and 82 is 81.5. Use the data set in problem 1. List the values that are to the left of the median. Then find the median of these data values. Mark this value with a vertical line segment in the list of the data values. So we're listing out the ones to the left. And then we're finding the median of these. Which would be 72. Because in between 72 and 72 is 72. Part B says to list the values that are to the right of the median. There should be 3 83s in here. So then in the middle of 84 and 86 is 85. There are 1, 2, 3, 4, 5, 6 data values here, and 1, 2, 3, 4, 5, 6 data values there. This last one got cut off just a little bit. In problem 1, mark the medians from part A and part B with a vertical line segment and label the values under the line segments. So I've done that in the problem. The data set in problem 1 is now split into 4 groups. What fraction of the data values are in each group? What percent is this? Well, if it's split into 4 groups, that would be 1/4 of the data in each section. 1/4, 2/4, 3/4, 4/4 to make the whole group or the whole data set. And then it also asks what percent is this? This is equal to 25%. Half would be 50, and a quarter would be 25%. Now we are going to label the median of the lower half of the data set as the first quartile, also known as Q1. So this median of the lower half is called Q1. Label the median as median in Q2. And then label the median of the upper half as the third quartile and Q3. Draw a box around the entire data set. Write the percent of data values that are in each section of the box. Said each one made up a quarter or 25%. So we're going to write 25% for each box. And I. Which value is closer to the median? The first quartile or the third quartile? How do you know? Well, let's look here. The first quartile is 72, and the median is 81.5. So how far apart are those? The third quartile is 85, and the median is 81.5. How far apart are those? The first quartile and the median are 9.5 away from each other. The third quartile and the median are only 3.5 away from each other. So which value is closer? That would be the third quartile. About what fraction of the data values are between the first quartile and the third quartile? Well, that would be from here to here. So that's 1/4 and 1/4 makes 2/4 or 1/2. It is 1/4 between Q1 and the median and another 1/4 between the median and Q3. What is the interquartile range of the data distribution in problem 1, and how do you know? Well, for range, we take the largest number and we subtract the smallest number. So interquartile means in between the quartiles. Let's go back and look at our interquartile values. Here we have 72 and 85. So we're subtracting the biggest number in our quartiles and the smallest number in our quartiles. So we need 85 minus 72 is an interquartile range of 13. That interquartile range phrase is abbreviated or condensed to IQR. The data set shows the number of potatoes used at a restaurant each Sunday for 21 days. List the data values in order from least to greatest. So let's look for the lowest number here. I see a 70. And there's a 72. And another 72. There's a 73. Two 77s. A 79. 1, 2, 3 80s. An 81. There's an 84. An 85. Another 85. Oh, I skipped an 84. Two 86s. Two 88s. A 90. And a 92. Then find the median, mark this value with a vertical line segment in the ordered data set. Since there are 21, if we split that into two groups, that would be 10 and a half. So we're going to put 10 values on each side, and we'll have one number in the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One value in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there's that value in the middle. So we're marking it with a vertical line in the data set. And we'll check off that we've done that. Now we're moving on to part C. C says find the first quartile. Mark this value with a vertical line segment in the ordered data set and label it Q1. It also says because the data set has an odd number of values, do not include the median in your list of values to the left of the median. So this 81 does not count in this list that we're looking for right now. So there are 10 values here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there should be 5 on each side of our line. 1, 2, 3, 4, 5. And then 5 on this side of the line. 1, 2, 3, 4, 5. So in between, we have 77 and 77. Between 77 and 77 gives us a Q1 of 77. And this is the median, also known as Q2, and it is on 81. Find the third quartile. Mark this value with a vertical line segment in the ordered data set. Again, do not include the median in your list of values to the right. So we need 5 here. 1, 2, 3, 4, 5. And there should be 5 on the other side. 1, 2, 3, 4, 5. So we've got that Q3 here. In between 86 and 86 would be just 86 for our third quartile. To find the interquartile range, remember range, we take the big number and subtract it from the smallest number. So we're taking Q3 and subtracting it from Q1. Which is 9. And interpret the interquartile range in this situation. So that's the middle 50% of the data. And in this case, that's on Sundays. And they have a range of 9. This problem is talking about potatoes. Here you can see they've marked the quartiles. We had 72 and 85. This one was 77 and 86. So you can see the interquartile range for the first set of data and then the second set of data. Here in problem 6, we have a summary of the information for the data distribution back in problem 1. And it says the median was 81.5. The first quartile, or Q1, was at 72 potatoes. The third quartile, also known as Q3, was at 85 potatoes. The mean, which they calculated for us, was 75.5 potatoes. And then that measurement of variability, the mean absolute deviation, how far the potatoes are away from the mean typically, was 10.7. Add a vertical line segment to the dot plot to mark the following information. The first quartile, the median, and the third quartile. In part B, we are going to use the mean, which was 75.5, the mean plus the mean absolute deviation, which was 10.7. So 75.5 plus 10.7 would put us at 86.2. And then the mean minus the absolute deviation. So 75.5 minus 10.7 puts us at 64.8. Which measures better describe the center and the spread of this distribution? The median and interquartile range, or the mean and mean absolute deviation? Explain your reasoning. The median and interquartile range better describe the center and spread. The median is a better descriptor of the typical number of potatoes used. The IQR calculation is based on the median. Recall that in a skewed data set, like we have here, the median is a better descriptor of typical than the mean. In a symmetric one, you may choose a different version of center to describe what is typical. Thank you for following along with lesson 13. If you're ready for lesson 14, you can check back in the playlist.